There is a solution to this problem. And again, the problem was that if we have a Grignard reagent reacting with a carboxylic acid, we would expect a ketone to form, but we actually would end up with a carboxylate, which is the least reactive of the carbonyl compounds. So you won't get a ketone. However, if you do react a carboxylic acid, and let's draw the carboxylic acid. With the organolithium reagent, in this case methyl lithium, you can get a ketone. However, before we even begin drawing arrows, I'm going to show maybe the first step or two, and then we're going to draw a long arrow saying it's going to end up with a ketone, simply because we will encounter some of this in chapter 21, and throwing it all at once right now can make it a bit difficult. So what's going to happen is that this is going to deprotonate the carboxylate oxygen. So you will have now carboxylate. So then you would say, well, this is what we had before. There's no difference. How come the reaction is... So if you notice, we compare, still have the same thing. Carboxylate, which is the least reactive. The difference here is that, once again, this is again more reactive. The organolithium is more reactive than Grignard. So let's write that down. More reactive than Grignard. So the reaction will continue. So we have another organolithium reagent. And this is from the bond, just to ensure that we have. So now we have our tetrahedral intermediate, but we have a problem here. We have two negatively charged oxygen atom, which is never good. However, we can protonate these. So you have H2O in excess here. You don't even need to write excess. You have plenty of water, and then this would end up in what you think is a diol, but it's not a diol. This has a name. It's called a hydrate. But we're going to just simply draw a long arrow where the process ends up with a ketone. Once again, we can discuss this in the next chapter, but about the hydrate and its transformation to a ketone. But for now, this is a reaction that you need to know. So again, carboxylic acid can become a ketone if you use organolithium. So once again, we're building up our arsenal of reactions so we can conduct synthesis problems. So again, make sure you remember that the main result in this reaction is the synthesis of ketones from carboxylic acids.